He's قليل. sorry أنا عندهم
Yes, yes, I can't hear you.
nothing.
Eh? Yassine, do you have any questions? Or you just keep talking with yourself?
لا أنا بس بقول لك إنها تطلع ورا عشان السيشن ديت بعد كده
Okay.
تدخل.
تمام. Okay, guys, we should start right now. As we mentioned yesterday, I had a video with your friends yesterday. We talked about the new chapter. We're starting a new chapter, chapter 14, lesson 1, talking about the properties of matter. And first, we mentioned what is a matter, and you guys really knew matter is everything that has mass and volume, which means it has mass and takes up space. I wanted to show you guys this picture in here. So this picture has two apples. They are the same mass, okay? But one full apple and one cut apple.
But
Cut
because they both are the same apple.
yes?
Because both are the same apple.
Yes.
It doesn't. If it's
Miss, I am here,
but
Miss, I am
different
here.
shapes.
Okay, Uday, you don't have to say I'm here. I know you here. I didn't call names yet. It's okay. I know
If
you.
it's the same mass and different shape,
You're not
so
so late, ya Uday. It's okay. Yes, so here they are different shapes. Yes, like Yasin said. They are different in the
I
shape.
said
Is it Yasin?
Tanah.
Tanahi. Yes, Tanahi. You sound like Yasin doing. Okay, so both of them are the same mass. They may be in different shapes, but they still have the same mass. So the shape doesn't matter with the mass itself. What shape the matter is doesn't actually change its mass. Yes, Hannah Sultan, you raised your hand. Do you have any questions?
Sorry, I entered late.
It's okay, guys. I told you you're not late. I know about the internet connection. Could be a little bit bad. So it's okay. I waited for you a couple minutes and then we started. We just started, okay? So again, the matter, what do we mean by the word matter? Everything that has mass and takes up space or has mass and volume. And you know now that everything is matter, you guys are considered matter. The air around us is matter, the water.
The light and sound is not matter.
Yes?
Light and sound
Light
is not matter.
mentioned yesterday. So there are some
Yes.
are not considered matter because they don't have mass or volume like the light. Well done. Thank you so much, Tanahi. Thank you for, like you still remember this from yesterday. Okay, so here we have, for example, another picture of different containers. Different containers you guys can see. So the shape of the water inside the container is different, right?
Yes, the water takes the shape of the container.
Yes, it's a liquid, so it takes the shape of the container. But can you imagine that those three containers have this volume of water, like the same amount of water?
Exactly the same amount?
Same amount, yes. Do you believe that?
Yes, I believe this because the glass is bigger.
Yes, it's changing the size. So the changing of the means
It will look as it's less water, but actually it's the same.
yes, it is the same. We now know that air is a matter because it has a mass and also it has a volume or takes up space. You can see this huge balloon. You can see people next to it. Can you imagine how big this balloon is? There are people walking next to it. Can you see that?
This is not a toy, it's a balloon.
No, it's not a toy. Let me zoom into the picture more so you guys can see it better. It's a big balloon in the street and people are pulling it down so it will not fly away. So air has mass and volume. It takes up space. So what's a volume? It's the amount of space an object takes up. The amount of space an object takes up. This is what we mean by volume. Okay? Okay, everyone?
Okay.
Yes. So if we have a certain amount of water or a certain volume of water, like the picture in here, as we change the container, will the volume of the water change? Yeah, the amount of the water will change as we change the container shape. Guys, did you hear the question?
No, it's not gonna change. It's the same amount.
Yes.
Not gonna change. So if I have a certain amount of water and I put this amount of water in different containers with different shapes, the volume of the water will not increase or decrease. It will actually stay the same because it's conserved. Okay, just like mass doesn't change unless I take something off. Like the picture in here, I had an apple, two apples, one in a full size or a full shape, and another one is cut. Did the mass change? When we changed the shape, did the mass change?
No.
No.
No, because we didn't change anything that makes up this matter. But what if I take a part of the apple away,
The mass will change. The mass will change.
the mass then will change, yes. So mass and volume do not change until you change something in the chemical formula or in what builds up this matter. Okay. Okay. So every up small. Yes.
I said okay.
I can't hear you. You got to say something.
I said okay.
Do we still have Uday with us?
Yes.
Uday, can you hear us well?
Yes يا مس أنا موجود والله.
I know you're here. I'm just asking if you can hear me well or not.
Yes, I am hearing.
So every matter is made of smaller particles. Is it better? Okay. So I want you guys to imagine having a piece of paper and cutting this piece of paper into the smallest possible part. This smallest possible part still carries the same characteristics of the paper itself. It may be so small, but still have the same features, right? يعني it's still
Yes.
paper, it's still paper, it's still a piece of paper.
Yes.
Okay, like gold, like carbon. All of those are made of smaller particles. We can say that this is the smallest
Atom.
possible particle of a matter, which we call atom. Yes, well done, Panahi. We mentioned this today. So we can see atoms like with our naked eyes because they're so small. I mean, I want you guys to imagine the cells, the cell that builds up the human body, for example. Imagine
Atom is even
cell.
smaller.
One cell, yes, one cell is made up of trillions of atoms. Trillions of atoms. Can you imagine that? So can you imagine how small the atom is? So this is the nearest picture we have seen of an atom. This is not an atom, not only single atom. These are actually group of atoms next to each other. So again, till today, we can't see an atom with a microscope. Even the highest efficiency microscope still can't be seen with the naked eyes. Okay, so here he's giving you an example of how small the atom is. So he's saying, think about the thickness of a crisp. Do you know the crisp? Like the chipsy pieces. It's like chipsy. So I want you guys to imagine how atoms are really small. Okay, so the number of atoms you would need to stack up to make the thickness of a crisp, I want you to think about it, is about the same number of crisps you would need to stack up to make the highest point on Earth, which is Mount Everest. This means 7 million crisps. Yani he's telling you guys how atoms are so small. He's saying that if you need amount of atoms to build up a crisp, you will need 7 million atoms to build up like one crisp.
يعني 7 million atoms عشان الكريسب الواحدة ولا عشان يعني thickness of one crisp.
And he wanted you guys to guess the difference. He's now comparing between chips or crisp and Mount Everest. So the crisp in here is like the atom for the Mount Everest. Do you guys understand this? Can you imagine how small the atom is then? Can you guys guess what does he mean or think what he means?
ان هو الو
Yes, I can hear you, Yasin.
is that um, I just want to know something يعني 7 million crisps دول يعملوا thickness of a crisp ولا one whole crisp؟
No, he's saying the 7 million crisps will be as same or as high as Mount Everest. So the crisp in this case is similar to the atom that builds crisps. يعني he's telling you مثلا إن إحنا عندنا I want you guys to think about it. هو عنده شيبسياية واحدة تمام؟
yes
الشيبسياية الواحدة دي هو عايز يشوف الاتوم صغيرة ازاي بالنسبة لها. فقال لك هخلي الشيبسياية الواحدة دي كأنها هي الاتوم وهحاول stack up يعني put it together to make it as high. تمام؟ بالنسبة لماونت ايفرست ال1 crisp بس دي تعتبر الاتوم. عشان ابني crisp شوف بقى محتاجة كام عشان اعمل 1 crisp واحدة بس. So he's just telling you how small the atoms are. Again, we cannot see them with the naked eyes. They are so small. I will show you now how small they are. So here we have a diamond. Can you guys see the diamond? Everyone, can you guys see the screen?
yes
So this is a diamond.
Yeah.
It's a matter. It has mass and space and stuff like that. And it's an element. So if I wanted to zoom in to see the atoms, for example, I will zoom in. Where is the, okay, here it is. Zooming in, as you guys can see. Now we can see atoms next to each other, but we cannot see a single atom. We can see a single atom. We can just see just atoms, small atoms next to each other. Now let's zoom more to see more atoms. So here we can see the bones that keeps the atoms together. Now let's zoom to see only one atom. Okay, this is how it looks like. Can you guys see that? Okay, let's now zoom into the nucleus, which is a part of the atom found in the center. Wow. Can you guys imagine how small is it? One atom.
That's so small.
Yes, it's so small. This one atom looks exactly like solar system. You know, can you imagine the sun in the middle and all planets are orbiting around it? It looks
Yeah.
بس في
It does
شوية
look like
yes?
that's every planet has its own orbit.
Yes. But here they are
It's
not
on-
planets. We have another name for them. They are called electrons. Electrons. So electrons, as you guys can see, are orbiting the nucleus. Now, when we zoom into the nucleus, we'll see it's made up of different parts, one red and one green. So we can say that the green ones are called protons and the red ones are called neutrons. We'll understand more about that. So, again, the atom is made up, even the atom has smaller parts. Can you imagine that? So the atom is the smallest possible part of a matter, and it's still made up of even smaller parts or smaller particles. We call them subatomic particles. So the atom is made up of proton, neutron, and electrons. So those are the three things that atom is made up of: proton, neutron, and electrons. So this is an atom in here. You can see in the center, we have the whole nucleus in the center. And the nucleus has protons and neutrons inside of it. Electrons are found on the outside, on levels or shells that they orbit through. Can you guys imagine now how atom is made up of? You guys can see that? Everyone? Guys, do you understand what I'm saying?
Yeah.
Yeah. Okay, can you hear me now?
Mr. Ocean.
Yes?
I mean, Mr. Fish and Mrs. Ocean.
Oh, okay, this is the internet connection. Okay, so here we are having a sample diagram of atom. So can you guys tell me now which part is which? Okay. Yes, some people are raising their hands. Okay, Hannah Sultan. So where should I put electrons, for example? Should I put them here or here? Where should I put them? Where do you think we should put here in this part? Hannah Sultan. This part, what should we put?
Proton.
Here on this level? Is that proton? Are you sure?
I don't really understand this part.
Okay, I thought you were raising your hand to answer the question. Let's get back, Hannah, and try to focus this time. So again, Hannah, we said that up of different parts. So this is how atoms are so small. If we get back to the diamond, we try to zoom to see one atom that builds up the diamond, and it's carbon atom. You would see that this is how it looks like. If I even zoomed more, you would see that it has nucleus in the center, which contains protons and neutrons. So basically, one atom is made up of 3 parts: protons, neutrons, and electrons. Okay?
Okay.
Okay. So these are the subatomic particles that build up one atom. So all atoms in the world are made up of these 3 parts. Yeah, you can find these 3 parts in atoms. Whether it's an atom for carbon, it's an atom for iron, oxygen, all atoms must have these 3 parts: protons, neutrons, and electrons. Okay?
Okay.
Okay. Now, where are they found in the atom? So this is a whole atom, Hannah. This is how the atom looks like. You can see it has nucleus in the center, and the nucleus have protons and neutrons inside of it, okay?
Okay.
We said proton and neutrons. Protons
Yes.
and neutrons are found inside the nucleus in the center, okay?
Okay.
Okay. Now we still have one part left, which is the electron. Where are electrons, or where are electrons found? They are found around the nucleus, orbiting the nucleus.
Okay.
Can you see these levels?
Yes.
Yes, these circles. You can see these small poles there. Those are the electrons. So if we get back to the picture of atom here, you would see the nucleus in the center, and all the electrons are orbiting it in levels. Can you see that?
Yes.
Yes, so this is how the atom looks like.
Okay.
Okay, and the atom is the smallest possible particle of any matter. Okay, so here he's showing you the atom. Now he wants you to tell us where is electrons. For example, what should I put here on this part? Should I put nucleus, electron, proton, or neutron?
Electron.
What should I put in on this one here?
Electron.
I can't hear you, Hannah. Said?
Yes.
Yes, well done. Thank you so much.
You're welcome. Thank you.
Have Hannah, where should we put nucleus? Up here or here? Where should we put nucleus? Up there?
Down the electron.
Here? Here?
Yes. The first place.
Are you sure? Putting to the nucleus or protons and neutrons?
Miss?
Yes, where should
The electron is nucleus.
electron is nucleus?
Under the electron is nucleus.
Should I put nucleus here?
Yes.
Are you sure?
Yes.
let's
No.
answer with your friends. Aysel, what do you think, ya Aysel, about this question?
As the upper part.
Upper part. Hannah, look carefully. Try to look carefully at this. He's actually pointing
Yes.
only, and then you
All right.
all of them.
I was confused between neutron and nucleus.
Okay. No, neutrons are subatomic particles. They are found inside the nucleus.
Is then the electron.
Okay, so what do you think is under the electron or here?
Under the electron is neutron.
Neutron, okay. And proton.
This person.
Think now? Yes, that's right. Well done. Thank you so much, Hannah. So do you understand now?
Yes.
Yes. But now let's check the mass and so as we said, every atom has these three subatomic particles: protons, neutrons, and electrons. Every one of those has mass and a charge.
Okay.
So, guys, if you're not using the mic, please try to mute yourselves. So one proton has only one mass. So 1 for 1. One proton has 1 as mass. And also 1 positive. So one proton has 1 positive charge. Okay? Guys, I can hear a baby crying in the background. If you're not using the mic, please mute yourselves. Okay, I think it was Reem. So one proton has 1 positive charge. Now the neutrons. Okay, Reem. Stop playing on the screen, please.
يا مس غصب عني.
Oh, okay, yeah, Reem. Okay, I know. Now neutrons are found also inside the nucleus. They have 1 mass, but they don't have charges. That's why we call them neutrons, from the word neutral, which means has no charge. Okay? Then we have electrons, and they don't have really much of a mass. They are like almost 0, but they have 1 negative charges. Why should these things have charges? Why do you think they should have charges?
They don't move.
You don't know that?
They don't move.
Well, if they don't have charges, for example, electrons will move away from the nucleus. What does that mean, miss? Well, here in this,
They're like magnets.
in this picture on the right, you can see the nucleus in the center, right?
Yes.
Yes, and the nucleus has protons and neutrons, right? It has 2 protons
Yes.
and 2 neutrons. Yes. So what do you think the charge of the nucleus will be? It has protons in it and neutrons.
High.
It will be positive or negative?
Positive.
Positive, because it has protons and neutrons.
Yes.
Protons have no
If it
charge,
doesn't,
so
if
protons
it doesn't have protons, so if it's not positive, the protons will go away. They would not keep orbiting it.
okay, Tana.
Right?
Finish. Yes, it's like almost right. Yes. Well done. But just let me finish this one, okay? So as you said, the nucleus will be positive because it has protons in it, and protons have positive charges and neutrons have no charges. You are right about this. Electrons around the nucleus have negative charges, while the nucleus itself is positive. So that's what makes electrons orbit the nucleus, just like the sun and the planets. The sun has the strongest gravity. That's why it keeps all the planets around it, right? Right, ya shabab?
Right.
Yeah. In this case, the positivity of the nucleus and the negative, or how negative the electrons are, is what keeping the electrons orbiting the nucleus. If they have no charge, like Tanahi said, if they had no charges, they would move away and we will never have atoms. Right?
Yes.
So the charges are important to keep them in place. So we have, again, protons, they are positive, electrons are negative, while neutrons, from the word neutral, they don't have any charges. So the mass of one is proton, right? So what do you think is located in shells and orbiting the nucleus? What do you guys think? We have Yasin Sadat.
What?
Yes. So here we have different options and we put them in each part, okay?
Yeah.
بس انا عارفاه قوي. بس انا عارفه السؤال ده.
Here you can answer.
يعني located البتاعة دي هتحط في electrons.
Electron.
برافو عليكي، برافو. Now it's Yasin's turn. Yasin, where should we put negative charge? Thank you so much, Reem. Thank you for being so active. Well done. Now, where should we put
أقربها بس ماشي. Negative charge تبقى في neutrons.
neutrons? Are you sure? Put it here.
البروتون
miss, no.
البروتونز.
Proton.
Electrons,
wait.
miss, electrons,
Electrons,
because the charge,
Yes, Yauday.
negative charge.
It has negative charges. Yasin, try to focus, please. Okay?
Positive charges.
Abdurrahman
Miss, can I answer?
Tanahi, where should we put the positive charge? Where?
Wait. Neutron.
We should put it in neutrons?
No, protons.
Protons. Okay, now relative mass almost zero. Where should we put this? Like it doesn't have any mass. It's so small.
I know.
I know.
Yes, Uday, where?
Neutron.
No.
Electrons.
Electrons, yes. They're almost zero. Okay, yeah, Uday.
Relative located in the nucleus. Neutron.
Electrons are located in the nucleus. And they have mass of 1, yes. And they have no
Yes.
charges. Where should we put this one?
Yes.
Yes, they do not have a mass charge.
Which one? Neutrons, protons, or electrons?
Neutron.
Neutrons. Well done, Yauday. Located in the nucleus, it's proton. This is the last one. Well done, guys. Okay?
Okay.
So, I think that was for today to learn about atoms. Next time, we'll learn about atomic number. We'll watch a video first. I will take names and then we'll watch a video about atoms, and that will be the end of today's session. Okay? Inshallah, next time we'll continue with the atomic number and mass number and other numbers, a lot of numbers. Okay? But I believe it's going to be fun for you guys. So, do you have any questions before leaving?
No, thank you.
So let's watch
Nope.
the video first, and then you guys are allowed to